believe Joel was asking about, is there a difference in the interpretation of regression results, whether you have one independent variable or you have many independent variables? And so I said, let's look at our little summary page here. So you want to specify the formula that you want, and I said in Excel you have to make sure if you have more than one x variable that they're all adjacent to each other. And so I was pointing out I have this car price data that I could maybe make visible to you all. And if I wanted to run a regression where I'm predicting the price of a used car, and I have the mileage of these used cars and these other aspects of the car, I could just run a regression with price as my dependent and mileage as my independent. If I wanted to say, well, I want more than just the mileage as my x variable, I want to include how big the engine is, I guess how many cylinders it has, how many liters it has, how many doors the car has, cruise control. If I wanted to include these other ones, then if I want to run a regression in Excel using the little data analysis thing, it doesn't like that there are these variables in the middle that are kind of getting in the way. So if I wanted to use these other variables in my regression, I would have to cut them and kind of squeeze them in, insert them over here. So just so that I can say, this is my y variable, and all of these are going to be my x variables. So I'll run a regression in a second just to show you what it looks like. Form hypotheses about these expected signs, or even the magnitude of your, this is supposed to be B's, not of your BS. Yeah, I guess you should have an understanding of how much your BS factor is, but these are supposed to be B's. And it kind of annoys me when people try to make something plural by putting an apostrophe S. That doesn't make it plural. That means that this single B owns something. So I want to take that out. But so hopefully you realize that this is your B's and not your BS. I probably made a joke about that in the video, as mature as I am. So let's go back to my car price, and hopefully the size of these variables will show up on the video. So here's my prices. I have some guesses about the relationship between the mileage of a car and the price, how big the cylinder, liters. So again, just come up with some guesses about what I think the signs of these coefficients are going to be. Well, I would presume that if a car has more miles on it, it's going to drive the price of the car down. So as the mileage increases, I would expect the price to decrease. So I'm going to guess that mileage should probably be negative. The cylinder, I don't even know if I have other size car. Oh, 8 cylinders in here. Okay. So there's a couple other, there is some variation in this number of cylinders. I really know nothing about cars, but I think I know what the cylinders are. I think having more of them makes your car go faster or something. So I'm going to presume that if there's more cylinders, that's going to, again, make the car nicer, more powerful. So that should drive the price up. So if the relationship between cylinder and price should be positive. Same thing with the size of the engine. The liters of the engine should be, the bigger the engine, it should be, again, more powerful car, which should make it more attractive and more expensive. So it should be a positive relationship between this liter variable and the price variable. The number of doors, I'm sure this probably goes between 4 and 2. Yeah. I can see where having 2 doors is a sportier car, and you might presume that someone who wants to buy a sportier car, they don't care as much about price. They're out looking for the wow factor of the car. So, but then I might say, well, if there's more, a 2-door car is going to be smaller, and so people don't want to pay if they're not getting as much size of the car. So a 4-door car is roomier, and maybe people prefer that. So I don't know if I have any sort of strong belief about what I think is going to be the relationship between doors and the price. So I'm not quite sure about that. Cruise control, are there any that don't have cruise control in here? Yeah, I guess there's a few. Cruise control is a nice feature, so I would imagine that should be a positive relationship between having cruise control and the price. Let's see here. On this Excel sheet that I have, some of these variables might not make a whole lot of sense. So I've got the cruise variable here, and it gives a little description of it. So this is an indicator variable representing whether the car has cruise control. So if you look at the data, it just has a 1 or a 0. I mean, it does show a 0 sometimes. So there's some zeros here. So this, let's do these 2 Chevy Aveos. So this Chevy Aveo doesn't have cruise control because it has a 0 here. And again, the notes say that if it does have cruise, then it's going to give that variable a value of 1. So this one does not have. It has a value of 0 in that cruise column. So this Chevy Aveo does not have cruise control, but this one does. So again, I would presume that having cruise control is valuable to people, and so there would be a positive relationship between the cruise variable and price. Because again, as the cruise variable increases, or it goes from 0 to 1, then I would assume that would push the price up because people value having cruise control. The sound variable is also a 1 and a 0. Indicator variable representing whether the car has upgraded speakers. So a 1 means it has upgraded speakers. Well, upgraded presumably is more valuable too. So I have my non-cruise Chevy Aveo here, which does have upgraded speakers though. And then I have my cruise Aveo, which doesn't have upgraded speakers. But anyway, again, I would presume that having a better sound system, having upgraded speakers would push the price up. So again, a positive relationship between sound and price. Leather interior, okay, leather seats. So another indicator variable representing whether the car has leather seats. So a 1 means it's leather, a 0 means those seats are not leather. Some people probably like it, so I would presume that the relationship between leather and price should be positive too. So I've come up with my guesses. Run my regression, okay, got to do that. If I just did a single regression with one independent variable, so I'm going to say my Y range will be the price, and my X range, I'll just do the mileage for now. So I selected column A1 all the way down to column A805 for my Y range. My X range, column B1 down to B805. I included row 1, which is the row that has the variable names or the labels. So I got to hit that box so that it knows. And I may have discussed it in the video. I don't have any presumption that the intercept here should be 0. Well, maybe when we do some regressions later on in the semester, I'm sure I'll talk about this option at that point, because there are going to be some regressions that we run where we do assume the constant or the intercept is going to be 0. But for now, I don't. So I'm going to, let's see, spit out a new sheet at some point. I'll hit OK. So here's my results. I have pretty abysmal R-squares, adjusted R-squares, 2% on both of those. So that's pretty awful. Remember that if you only have one independent variable, then the R-squared itself is not misleading. I mentioned that if you add independent variables to a model where you have more than one, then the R-squared can be a little misleading because it never goes down, but the adjusted R-squared can go down if you're adding independent variables that don't make any sense. But in this case, I've only got one, so I don't really need to worry about it. So my R-squareds are pretty bad, so I probably don't have a lot of confidence in this model anyway. But what else do I see? I have this coefficient here, or the intercept term. So if, well, I'll just keep going. I have this mileage coefficient of negative 0.17. What do the coefficients mean then? Again, the intercept term tells me what is going to be the expected value of price in this case if all the other variables are 0. So if mileage is 0, if you had a used car in this data set that didn't have any miles at all, if the entry for the mileage variable was 0, then the expected intercept or price would be 24,764. So a car without any miles at all would have this expected price of 24,764. What the mileage variable does is, let me go back to the notes just to make sure. Mileage is just the number of miles cars have been driven. Okay. Price is 2005, blah, blah, blah. So what this mileage coefficient is telling me, again, all the coefficients tell you if there is a 1 unit change in this X variable, then what happens to the change in the Y variable? So if there's a 1 unit change in mileage, which is a little weird to talk about because, you know, this car has 22,000 miles, 32,000 miles. If you were to increase the mileage by 1, like just adding 1 more mile to a car, then what it's going to do is it's going to push the price of the car down, which we expected it to push it down. Right? So I see this negative coefficient out here, or negative sign. So my hypothesis about the relationship between price and mileage was correct. I expected those two to be inversely related or negatively related. But what it's telling, what the number is telling me, is that if a car has one more mile added to it, then it pushes down the price of the car by 17 cents. I guess it's a good trade-off. So again, I'm getting the coefficient in the correct direction. Do I know whether this is a reliable estimate? Do I have much confidence that should I have much faith in the fact that the actual relationship between mileage and price is this negative 17 cents? Well, that's when I need to start looking at the t-stats and the p-values. And for the mileage variable, which is what I'm concerned about, that t-statistic is over 2 in absolute value. I mean, it's negative 4 instead of negative 1.5 or something. So it's bigger than negative 2. And again, I can kind of verify that by looking at the p-value. The p-value is actually very small. It says 4.68, and you might think that seems big, but it's got the little exponent sign over here. And so it's e to the negative 5. So this is actually 0. Well, let's do this. If it's 4.68, then I have to move the decimal place to the left 5 times. So I move it 1 to be in front of the 4. That's 1, 2, 3, 4, 5. So this p-value is actually very, very small. Again, anytime we have there's different standard levels of p-values. If you say something is significant at the 10% level, then you want a p-value that's less than 0.1. If you have a p-value less than, or if your variable is significant at 5%, then you want a p-value that is less than 0.05. If your variable is significant at 1%, then you want a p-value less than 0.01. And this one's much smaller than that. So it's very significant, meaning it doesn't mean that, well, when we say that the mileage variable is very significant, the only thing that means is that I can have a lot of confidence that the relationship between mileage and price in the model that I have is 17 cents. There would be no reason to suspect that the relationship between mileage and price is like 25 cents or negative 13 cents. So we've estimated this variable pretty well. You might say, well, yeah, but it's only 17 cents have an effect on a car that's on average, 20-something thousand dollars. 17 cents isn't that big of a deal. So you might be like, well, that's not significant. 17 cents to the price of a car is not significant at all. Well, again, but when statisticians or mathematicians or whatever use the phrase, this variable is significant, they're not meaning that mileage is necessarily hugely important, but they're just saying that this coefficient that was estimated by the regression, you can have confidence that that is a well-measured relationship between the mileage variable and the price variable. So, and again, some of this other stuff I don't tend to focus on too much, at least in the class, so you don't need to worry about it either, like the ANOVA stuff or these confidence values over here. We were also asking about using some other variables and whether the interpretation would change. So why don't we say, well, I think that the price depends not just on the mileage, but on some of these other factors too, like how big the engine is. Let me just go back to these notes. Cylinder, number of cylinders, engine size. Okay. Since the number of cylinders is, it only kind of varies between 4, 6, and 8, but the liters varies a bit more, so I'm going to use that instead. Why don't I do, so that means I got to move this cylinder variable then. I'll move it over here for now. I'm going to do a regression of price again, which is, it's still kind of, it remembers what I picked last time, so A1 to A805. And I want my Y range now to be, I'll do mileage and liters and number of doors. Just do those 3 independent variables and select all those. Want my labels again. I want to make a new sheet. Hit OK. Got my next sheet here. Let me make it bigger. I'm going to, let me cut these. I'm going to put them over here just so we can have them side by side. And again, let me get rid of some stuff that we don't really need to focus on too much. I've added more variables here. You can see that I improved my explanatory power quite a bit. I went from being able to explain only 2% of the variation in price by just using this variable mileage. But when I use these 3 variables, mileage, liters, and doors, I can explain almost 1/3 of the variation in price. So just adding the liter and the doors and the way those 3 variables kind of interact with each other, that really improved the explanatory power of the model. So that was nice. My intercept here again, it actually fell quite a bit, but I'm not too concerned about that. I mean, if you had a car with 0 miles, that's good. If you had a car with 0 miles, that would push the price of the car up. But if it also means that if you had a car that had 0-liter engine and 0 doors, then that car would be still $13,000. Someone would pay $13,000 for that car. So again, a lot of times, unless you're specifically trying to look for some value of the intercept, if you have some guess beforehand about what you think the intercept of this equation should be, a lot of times we don't really focus on it too much because it just it becomes kind of a kitchen sink sort of thing where any of the leftover variation that we can't explain, like the other 66% of this variation in price, it gets kind of funneled into the intercept. So what I'm most interested in are these other coefficients that are here. And before, I said that, well, I think that the higher mileage should lower the price, so this is negative again, just like it was over here. We thought that the larger liter engine should push up the price, and the liter now is positive. That's good. And I wasn't quite sure about doors. I said maybe it could be that only a 2-door car would be preferred. A 2-door car might have a higher price because of people liking the status of it. But then I said maybe a 4-door car people would like more because of the roominess. But it appears that when the number of doors decreases, that pushes the price up. So if doors goes down, it pushes the price up. There's this negative sign out front. So it seems like my first hunch was probably correct, that people like these cars with fewer doors on it. They're sportier. They look nicer. They're willing to pay more for them. So I get a negative coefficient for that. Again, interpreting these things is done exactly the same way. So I'm sort of looking at the R-squares the same way I did before in sense of, well, this was a 2% explanation. This is a 33% explanation. And again, since I have more than one independent variable, then I might focus a little bit more on just the adjusted R-squared. So again, 33.6% is pretty good ability to explain a car's price using just these 3 variables. So that's pretty good. Again, I don't have a whole lot to say about the intercept term itself. I see that the mileage, the effect of the mileage fell a little bit. So when I only had the mileage variable, it seemed like adding a mile to the car pushed the price down by 17 cents. But here in this more complete model, adding a mile to a used car pushes its price down only 16 cents. So I've lost a penny of the effect of the mileage. And again, I would tend, if I'm trying to compare these two models, I would probably, just given the fact that the R-squared is a lot better, and I also see that it's still significant here. I mean, this estimate of 16.2 cents is still significant because the p-value is still really small. It's actually a little bit smaller than the other one was. So I would still have confidence that, okay, it was 17 cents over this first model, and now here, when you have more variables involved and a better explanatory power, it seems like the true or the truer effect of mileage on price is about 16 cents per mile. Now these other factors in here too, so I have this big 48.98. This looks big, so you might be like, man, it seems like the mileage doesn't matter at all because that's only 0.16. But this liter variable is 48.98. It's so big. And even the doors, where it's 11.34, those both seem so much bigger than this puny 0.16 coefficient on mileage. But again, it all depends on how you're measuring these variables. So liters, well, if I go back, the mileage variable is in the 22,000, 29,000. Those are pretty big. And the liter variables is like 2, 3. Those are all pretty small. So of course, the effect on price if I increase this variable from 2 liters to 3 liters, that's a pretty big step up as far as the engine performance is concerned. So again, going from a 1-liter car to a 2-liter car or a 2-liter car to a 3-liter, that's a pretty big step up in how the engine does. So the fact that it has this pretty big impact on the price isn't very surprising to me. The mileage variable, again, well, this car here is 22,021. Well, what if I add one more unit to that to make it 22,022 miles? Well, again, the effect on the price is going to hardly be anything. I mean, 16 cents. But again, it doesn't mean that mileage is unimportant. It doesn't mean that the liter of the car is the most important thing in the world. The size of these coefficients just reflect the size of the variables that are underlying the data to begin with. So again, just seeing the size of these coefficients be very different doesn't mean that liter is more important and mileage is not. But anyway, so it's positive. It's good. And again, I kind of explained if you went from a 3-liter, do they have 4-liter cars? I don't know. If you go from a 2-liter car up to a 3-liter car, or a 1.8 to a 2.8, then it bumps up the price almost, $4,900, which is pretty big. And I see my t-stat is huge. It's a lot bigger than 2, 18.9. And my p-value is tiny, which is, again, demonstrates that the measurement of this effect I should have a lot of confidence in. So, again, if I'm trying to figure out what's the relationship between liters and price, I can have a lot of confidence that that effect is right around $4,900. I go to doors here. I see it's negative. So, again, we talked about that interpretation. And it's 1134. And again, those only vary between having 4 doors and 2 doors. When the door is variable, it's going to be a little weird to talk about it this way because these coefficients represent a 1-unit increase in your independent variable and what that does to the dependent variable. So even though the only types of cars I have are 4-door and 2-door cars, Excel doesn't know I'm talking about cars. Excel just sees a column of data with 4s and 2s in it. And so it's still going to report a coefficient that tells me what happens to price if there's a 1-unit increase in this independent variable. So the way you have to interpret this is to say, well, if the number of doors increases by 1, so if I went from a 2-door car to a 3-door car, which doesn't conceptually make any sense, but that's how I have to interpret this variable. So if I increase the number of doors by 1, then it pushes down the price of the car by $1,135. And its t-stat is good. I mean, it's bigger than -2. Its p-value is low. So again, I can have a lot of confidence that the estimate of this coefficient is done well. And so you might be like, well, nope, there's no 3-door cars out there. So you could just go, well, what happens if there's if you increase the number of doors from a 2-door to a 4-door car? Well, you just multiply this coefficient by 2. Because again, this is the effect of increasing doors by 1. So if I want to add 2 doors to it, go from a 2-door to a 4-door car, then I can just multiply that coefficient by 2 and presume that having a car with the same mileage and the same liters, if the car suddenly is a 4-door instead of a 2-door, then that should push the price of the car down by $2,270.